Welcome to Lesson 4, and Lesson 4 we'll be looking on electro hydraulic system. So the question is, why electro hydraulic? Initially, the reason why they implement electro hydraulic because it was very difficult for some vehicles to install the conventional hydraulic system because the engine was located at the back, and then it required a lot of pipes and components. So some manufacturers choose to go with electro hydraulics. In addition to that, some engines were fairly small and the pump will normally rob the engine of some of its horsepower. So as such, they choose to go electro hydraulic. But in many cases now, you find that electro hydraulic is mostly used on like pickup, SUV, and those bigger units. Why? Because to use a traditional EPS system, which is the norm nowadays, EPS, you'd need a big motor or a motor that consumes a lot of current, because in the motor vehicle, it's either we are working with 24 or 12 or conventional system, of course, and for pickups, SUV, they are still working with 12 voltage. So in order to steer those vehicles, you would use a motor that consumes a large amount of current. That means big battery. Probably they don't have a space for it, or they have a big alternator. So let us look on electro hydraulic now on this diagram. Pause. So welcome to our electro hydraulic system. Here it is, electro hydraulic. And as you can see, the picture that I have here is just a retrofit of our conventional hydraulic system. Where we have the pulley, we will remove that pulley that is driven by a belt from the crankshaft and we use an electrical motor. So the hydraulic system is still the same technically, but where we have the pump and the pulley, we'll remove that pulley and that belt and use an electrical motor. This electrical motor is what we call a duty cycle electrical motor. As you can see, you notice that is going up and down. It's a duty cycle, percentage off on, percentage off. Then we have the ECU that will operate this motor. So this ECU, electronic control unit, which is the ECU, it will operate this motor. This ECU, of course, without getting a grounds, most likely can get it from the frame, from the chassis, or it can get a computer grounds or both. We'll have a B plus battery positive, and sometimes this battery positive might probably just go to the motor, or it can come through the ECU. And this is what carry the high current. Then we have a 10 amp fuse or a 5 amp fuse to activate the ECU. And then this critical component, you remember in the first video we were looking at steering column mechanism. The vehicle will have a steering angle sensor somewhere on the steering shaft where the steering column mechanism is. Then the ECU will need something like vehicle speed sensor. It can get it from a dedicated cable or from a network system, but this is assume that everything is a dedicated cable, no network system. And we'll have information also coming from the powertrain control module, the PCM. So as I can see, the ECU will be getting information from the battery, the steering angle sensor, the vehicle speed sensor, and the powertrain management system. And when all of this information is sent to the ECU, then now it will operate our electrical pump. Note, the pump only need to operate when the vehicle is going extremely slow or the vehicle is stationary. Once the vehicle is driving anywhere probably from 40 kilometers up, you don't need any form of power assist. So when the vehicle is driving at high speed or medium speed or cruising speed, this pump is technically off, not working. So what that does, that saves the engine. Unlike our conventional hydraulic system, where the belt is constantly being driven by the engine, whether the driver is going fast or is going slow, power is being used up. In this case, this system is using indirect power because the alternator will have to produce the energy to charge a battery and produce the necessary energy for the motor to operate. So this system is using electrical energy, and the more current the alternator produces, it's the more load will be on the engine. So it's not free power, it's not a free for all. It is consuming engine power, but it only consumes engine power more efficiently because based on the steering angle, the vehicle speed, and information coming from the PCM, and the vehicle speed in most cases coming from the ABS car. That's how we have modern system nowadays. But from the vehicle speed sensor also, whichever. So based on the vehicle speed, the steering angle, and the powertrain control module, this information will then send to the ECU, and then the ECU will determine how much assistance the driver would need to operate this pump. So as I can see, the pump, the reservoir, and some system have something that we call an accumulator, can all built in one unit. All of this unit right here, it can place anywhere convenient to the manufacturer, but in most cases it will place where our modern EPS system is, and this system want to look similar to an ABS modulator. It's not very common, not many vehicles have electro hydraulic system, although hydraulic systems still have some good advantages when compared to EPS, and it is good. But speaking from an economical perspective, the hydraulic system is more expensive. That's why most manufacturers still, they just go ahead with the EPS. And with this hydraulic system, of course, things like our electronic stability program can be easily integrated in the system. Alright, because we have a steering angle sensor to give it some feedback. So as you can see, it works just like the conventional hydraulic system from a hydraulic perspective. We still have our control valves, we still have our power cylinder, we still have fluid going to our control valves, and then depends if we turn the vehicle left or right, fluid will go into our power cylinder, and then we have our return line. And the difference with this is that we have an electrical motor that operates by the ECU. The ECU will need all this information from the steering angle sensor, vehicle speed, from the PCM, powertrain management system, and of course we have our warning light. So if the system becomes defective or if there's any electronic failure within the system, the driver can know. And of course we still have our tire, our rack gear, and of course our pinion gear. So what they're technically doing is retrofitting a hydraulic system. Where the pulley is, they put a pump, and with this pump right here, notice I use motor because the motor will be driven by, the pump is right here, so we still have electrical motor. So this electrical motor will drive the pump, and that is the advantage of our electro hydraulic system. It's more precise, consume far much less energy on the vehicle, because when the vehicle don't need this motor assistance or this power assistance, the ECU will just cut power from the motor. When it is needed in tight corner, driving slow in small little areas that you barely can move and you need maximum assistance, then the ECU will activate the motor. And how the ECU will know how to activate the motor is through the steering angle, vehicle speed, and of course from the PCM. Alright, so this is our electro hydraulic system. Physically, it looks just or similar. Rack and pinion control valves, we will see those components with our electro hydraulic system, where we'd have the pulley, electrical motor is there to do the driving. So at the end of this lesson, we know the parts that make up the electro hydraulic system, which is just an addition of the hydraulic system. We know the operation of the electro hydraulic system, And of course, if there's any failure within this electronic right here, you can use a diagnostic tool and diagnose the system. So you can actually scan the system to find out if you're not getting any power, if the motor amps too high, or there's excessive resistance in the motor, if there's no steering angle data going into the ECU, if there's no vehicle speed data getting to the ECU, or if there's no PCM data getting to the ECU. When I explain my EPS system, I will explain how the network works, because this system, we call this what, dedicated cable. In the more modern system, we don't have so many dedicated cable. We just have two twisted pair copper cable going to the ECU that carry information like the steering angle, the vehicle speed, and the PCM data. But in our EPS system, we will explain that. EPS means electronic power steer. Alright, so that's the end of our Electro Hydraulic Power Assist. Thank you.